Hi, welcome to Azure User Group Sweden. Happy weekend, everyone, and thank you for tuning into our live stream today. Our welcome back from the summer break. Hi, Håkan, how are you?
Yeah, I'm really fine. How are you, Jonah? How was your
I'm
vacation?
I'm great. I'm like recharged and reloaded for the coming spring. Yeah, so I just got back from my 3-week vacation from the Philippines. So yeah, I got some ton.
Oh,
Yeah, how
nice.
about you? How was your summer break?
I was really great. Was traveling a little bit back and forth between Sweden and Norway, so
Oh,
that's
yes,
nice.
very Nordic.
Mm.
Yes, yes. So, hi everyone. I see that our friends, common friends, are already saying hi. So, we have our friends Thomas saying hi. We have Stefan, welcome back, and also Ashish that said hi. And let's see. Yes, thank you, Hashish. Yes. So today we will be having a session about Kubernetes scaling with KEDA on Azure. And before I start, probably there are people that are new in our stream right now or our session joining us for the first time. So I would like to take this opportunity to share about Håkan, my co-community leader of Azure User Group Sweden. Håkan is Microsoft MVP for AI. He is also a Microsoft certified trainer. He is the co-leader of this group, of course, and by daytime, he works as a manager for data and AI enablement at Miles in Norway. And he is very active as a public speaker, and he is contributing to the tech communities at the Norwegian.net user group in Oslo, and also very active in AI community in Oslo and in the Nordics. So happy to have Håkan with me in this community.
Yeah, thank you so much, Jonah. So it's a real honor for me to introduce Jonah Anderson. So she's the founder of our user group. And in addition, she's also a Microsoft Azure MVP, a Microsoft certified trainer, a published book author, mentor, and also an international public speaker. And just very recently, she got a new job. So you want to
Yes.
tell us about that, Jonah?
Yeah, I actually recently transitioned consulting jobs to a new one. So I'm working as a senior with the role of Azure senior consultant at Solidify, a Swedish IT consulting company expert specializing in DevOps and Azure technologies. So it's really great to find a matching company that suits my passion and skills.
Yes, nice.
Okay, thank you for the great introduction. So, before we properly introduce our guest speaker today, we would like to share everyone our code of conduct. So, Azure User Group Sweden is part of Azure Tech Groups, and we follow a code of conduct. And we are expecting everyone, all of us, including ourselves, to be nice and friendly. If you're in our sessions or discussion, listen with purpose and be thoughtful. Be respectful to others. Seek to understand, not criticize. Be curious and feel free to share your ideas and be inclusive in your comments and questions. And if you feel that there's something missing or something that you need to bring up for this code of conduct, feel free to reach out to me and Håkan. And I also want to share about our Azure Heroes Learner Badger. Do you want to go ahead and share, Håkan?
Yeah, so we prepared a learner badge here and a learning path. If you want to learn more here about Azure Kubernetes services using KEDA, you can just follow this bit.ly link that we have, or you can scan the QR code here to claim your learner badge.
Okay, great. Thank you, Håkan. And to those that wants to join us later, we have this tradition of virtual fika for our virtual session. So if you want to have a one-on-one mingle with me, Håkan, and the speaker and ask discussion questions, feel free to save this QR code. We will also share it later at the end of the session so you can join us on Zoom. Great.
Oh, nice. Yeah, so then I think it's time here for us to introduce our speaker. So let us add him here to stream. So we are very honored to have Wolfgang Offner. He works as a freelance cloud architect in Toronto, Canada, and he has a focus on Azure, Kubernetes, DevOps, and .NET. And he is also a Microsoft certified trainer. Welcome, Wolfgang.
Hi, thanks for having me.
Welcome. Yes. How are you today?
I'm a bit tired because it's very early in Toronto, but excited to be here and talk about
Yes.
Kubernetes.
Yes. I did publish that you're from Switzerland, but we just heard that you moved to Canada. So
Yeah, I
yes,
just
yeah.
recently moved to Canada, so everywhere it still says Switzerland.
Yes. How is the weather in Canada today?
It's kind of cold. It's around 20-degree max,
Okay.
but I lived in Australia before, so that's a nice change from like 40 degrees. That's too hot, so 20 is great.
Yes, probably you have it better today. I think here in outside it's a bit cloudy in my area. How about in Oslo, Håkan?
It's actually raining today.
Raining.
Raining,
Oh,
yes.
okay. Yes, yeah. Yeah, talking about weather. All right. Let's properly introduce Wolfgang, what he does.
Yeah, so we have done
We have
that.
done that. Yes.
But
Yeah.
Wolfgang, do you want to say a couple of words here about your session? What you will be present?
Yes, today I'm going to tell you something about KEDA, the Kubernetes Event-driven Architecture, and how we can use it to scale our Kubernetes workloads. And I'm going to show you two examples, how to use messages in an Azure Service Bus, and how also use Azure DevOps agents that are running inside Kubernetes.
Okay. Exciting. Yes, I look forward to that. So, yeah, the stage is yours. And if you have questions to our audience, feel free to post it in the chat and we will ask it on the go to Wolfgang.
Okay, great. Then let's get started. So thanks for the introduction. As you have heard, I'm a freelance cloud architect. I recently moved from Switzerland to Australia and now from Australia to Canada. And I focus on Azure, Kubernetes, DevOps, and .NET solutions. If you want to get in contact with me or have questions later, feel free to reach out on LinkedIn, on Twitter, or on my own website. And today I want to give you an introduction about the history of the architecture and software projects. Then I'm going to introduce KEDA and why KEDA helps us with our modern applications. And then I'm going to show you two demo applications about scaling with messages in Azure Service Bus Queue and also with Azure DevOps agents that are running in Kubernetes. At the end of the talk, I'm going to give you my opinion of KEDA, and then we have some time for Q&A. But how Jonah already said, if you have any questions, just ask in chat, and these two can interrupt me, and I will answer them. If you want to have the slides, you can scan this QR code, and you can also find them on my GitHub page. Okay, then let's talk about the history of software projects in a very simplified way. So back in the days, we had a server-client architecture. It was very simple. There were only a handful of clients. There was no redundancy, no high availability. And if the server crashed and the client couldn't work, it wasn't such a big deal because there were only a handful and it was not too important. Then around I would say 20 years ago, we discovered that we can virtualize our server, and suddenly it was way easier to have redundancy, to have multiple servers. So we added load balancing, and we had a way better availability. The only problem back then was everything was done by hand. So we had static load balancing, and if you needed more VMs, someone had to create them, add them to the load balancer. So it was a slow and expensive process. And additionally, we had to buy all the hardware and keep them in our own data center. Then with the big revolution of the cloud, suddenly we could add new instances automatically. We didn't have to install them. We didn't have to buy hardware. So it was way cheaper, way faster. And we also only had to pay what we used. So if you used 10 instances, we paid for 10. If you scaled down to 3, we only paid for 3. And the scaling back then mostly was on CPU usage or RAM usage. But the problem nowadays is our software is getting more and more complex. So I don't want to talk about the details. I just want to give you an overview of what software could have. For example, we have some on-premise services. We can have some
Yes.
Hi. I think hi Håkan. I think Wolfgang probably lost us or lost the connection.
It seems so.
Yes, we will see if he comes back
Mhm.
in a few minutes. Probably a technical issue on his side.
By
Yes.
the way, meanwhile, I can ask you how much Kubernetes are you using or have you used before?
Me? I actually, to be honest, I haven't done so much AKS. I did try to develop with container apps and ACI with Azure, but not so much. So this is actually an interesting topic for me, and I am curious about you and the audience as well, like the community. How about you? How is it? How's your experience on the container
No,
development?
no,
How can?
very, very, very little actually, because you know in Azure Machine Learning you can either deploy
Mm,
to ACI or to AKS, but that's
okay.
almost automated. Now I think Wolfgang is coming back
Yes.
here.
Yeah. Yeah.
Ah.
Welcome back. Let's see. Let's put him back.
Yes.
Hi. Welcome back. Can you hear us?
yes, I can hear.
Yeah.
I'm so sorry. My cat got
No.
too excited and
Yeah. I.
ripped out all the cables.
Oh,
I I heard like some
yes.
mini noises and I
Mm.
was thinking, okay, is it the cat? Yes, that's good. That's good. Welcome back. Thank you so much. I'm glad that your cat is actively interacting with you in our session. Do you want to reshare your screen and then we can start over? Start again.
Sure.
We were discussing, Hokan and I, about our experience with this topic. I don't have so much except container development with ACA and but I see that some of our audience, like Ashish, is also interested to learn more about it. Okay.
Yeah, AC
Mhm.
also using KEDA.
Yeah. It's great.
So yeah, you will see,
Yes.
hopefully that's a great technology.
Yes.
Yes.
All right. We'll
Yeah.
let you continue. So I'll remove myself a note.
Okay, sorry for that. Let's continue. I was saying about the architecture that nowadays our software architecture has become very complicated. For example, we have some on-premise connections. Then we might have a Kubernetes cluster. We have different databases, like we have a Redis Cosmos DB, that's a NoSQL database. We could have SQL databases. We can have Java applications, .NET applications. So scaling based on CPU and RAM usage is probably not enough anymore because we have so many dependencies, everything's interconnected. And so we had to find a new solution how to manage our software. And one way to do that is Kubernetes. Kubernetes has a built-in resource that's a Horizontal Pod Autoscaler, or short HPA, and it can also scale our applications based on CPU and or RAM usage. But as said, the architecture gets more and more complex, so that's probably not enough. I already mentioned we have so many dependencies, everything is connected between each other, and often we also have to react to events that are happening outside our application. So, for example, if you put messages in a service bus, we have to scale out our application to process these messages. And yeah, there's so much more. There's like databases, if you analyze streams and see something there, if you analyze logs, for example, Azure Monitor, we see an error message there. Yeah, so much to react to nowadays. And just 2 more sentences about the HPA. It scales deployment sets or stateful sets inside Kubernetes, and it does this by adding or removing pods. In case you don't know, Kubernetes, a pod is, in a simplified way, a container. So you can just think of the Horizontal Pod Autoscaler just adds more container, and therefore you have more instances of your application. It can scale based on CPU or RAM usage, but you can also scale based on custom metrics. For example, you could query the custom metrics from the Kubernetes API, or you can also query from Prometheus. And an example of this query could be requests per second. The problem is, I, as a software developer, I don't really care about the Kubernetes APIs. I don't want to call or query Prometheus, so it's quite tedious for me to do. And on the other side, operations probably also don't want to do this because they don't know what our application needs. They might not know how to write these queries. So that's not a great solution. And here you can see the configuration of the Horizontal Pod Autoscaler. So on the left side, we have here how the configuration of the scaling. So we will have a minimum of 1 replica and a maximum of 10. And we try to have a CPU utilization of 50%. And here in the middle, we can see how to scale down. So we can say we scale down by 4 pods every 60 seconds, or we can say we scale down by 10% every 60 seconds. Excuse me. And the same with scaling up. We can scale up by a certain amount of pods or by a percentage. But as I said, the HPA scales mostly based on CPU and RAM usage, and with our modern applications, there are some limitations. A great example would be Black Friday. So you hopefully have in your online shop thousands or 10 of thousands orders, and these orders often get placed into a message queue and then are being processed later by different applications. So when your customer places the order, they get within like a second a message, thanks for ordering, your order has been placed. And then it takes like 15, 30 minutes until another system processes this message for this order. And the problem is if you have like 10,000 messages in your queue, and you can't scale accordingly. You have maybe 1 or 2 workers that are processing it, and it will take forever. Like if you have so many messages, maybe it takes days, weeks, and your customers won't be happy. So if you scale based on CPU RAM usage, you have no way to scale when you have so many messages in your queue. And this is where KEDA comes into handy. KEDA is the Kubernetes Event-driven Autoscaling. It's an open source project, and it's also a CNCF, a Cloud Native Computing Foundation project. And it just this week graduated, so it's a full project now. And it's maintained by Docker Planner, Microsoft, and Red Hat. So you can see there are big companies behind it, and there's a great community. You can join also the bi-weekly sessions about planning. You can ask questions. And what KEDA has is a so-called built-in scaler. So you can just use the scaler and scale according to your technology. So right now there's 62 built-in scaler. And as you can see in the list, there's every technology you could think of. There's like Kafka, a whole bunch of Azure services like Azure Monitor, Azure Service Bus, Redis, Prometheus, Elasticsearch, different databases. So I probably only used like 10% of all these technologies, so there's a whole lot. And if your scaler is not there, you can create it by yourself, create a pull request, and have it in the next version in KEDA included. Then the use cases of KEDA is, as already mentioned, you can scale accordingly to external events. For example, something in Azure Monitor happened, a message got posted into a queue, but you can also scale to 0. And scaling to 0 means that your application is not running and you only start it when you need it. A great example is serverless. So for example, on Azure, you have Azure Functions. They are not running except when you call them, or when something happens, then they start up and run. And with KEDA, you can bring this technology into your own data center. And a great way to use scale to 0 is to balance your resources better. If you go back to the online shop example, during the day, you have all the customers in your online shop, so you will have all the resources focused on the shop, so the users have a great user experience. They buy a lot of products. And during the night, usually you have very few customers. So you can scale down your online shop, but then scale out background services. For example, creating shipping labels, calculating loyalty points, creating invoices, and so on. And in the morning, all these calculations are done, so you can scale them back to 0 and scale out your online shop again.
Yeah, so Wolfgang, we have a question here from our audience.
Yeah, sure.
It is Samir who says, could there be any use case where we want to use KEDA in combination with HPA? And if so, do you have any example?
Yeah, that's something I'm going to talk about in, I think, 2 slides, because KEDA is using the HPA to do the scaling. So you will need both. But first, take a look how to install it. It's really very easy to install it. All you have to have is a namespace called KEDA, and then you install KEDA via Helm chart inside this namespace. So you can use the Kubernetes command line kubectl. You create a namespace. Then you can add here the KEDA Helm chart. Then you do an update just to be sure that you have the newest version, and then you do an install. It's going to take a couple minutes, and then you can see that you have 2 pods running inside this namespace. The operator and the metrics server. And the operator is responsible for scaling to 0 and from 0. And the metric server sends information to the Horizontal Pod Autoscaler. And if you don't scale from or to 0, the HPA is doing the scaling. And a great thing about KEDA is that you can just add it to application. You don't have to change anything in your application. So if an operator wants to add it, the developers don't even have to know about it, because it can just install it and it's going to work. And here you can see, coming back to the question, that we have the Horizontal Pod Autoscaler here. And if we scale from 0 or to 0 here, the agent does the scaling directly. And if there's more than one, or from 1 to more, or back to 1, then the horizontal autoscaler is doing the scaling. Additionally, we have here an external source. For example, later in the demo, I'm going to show you Azure Service Bus queue. And then we have here a scaled object that's doing the scaling. So it's going to check the external source, for example, Service Bus, if there are messages, and if so, then the scaling is going to happen. I already teased it a bit. There are two resources for KEDA, the scaled object and the trigger authentication. The scaled object is to configure the scaling, and the trigger authentication is to configure the authentication to the external resource. For example, if you have a database, that could be the connection string or some keys to authenticate to whatever source you're using. So here we have the scale object. It's also of type scale object in Kubernetes. Then we have a scale target reference. That's the name of the application you want to scale. In this case, it's KEDA demo API. And then you have here a couple parameters. For example, the minimum amount of replica, the maximum. So that's 0 and 10 in this case. The polling interval is how often KEDA checks if there is a change. And the cooldown is how long KEDA waits after a scaling event happened. So if you scale, then KEDA waits 30 seconds and only then checks again. The default values for these two are 5 minutes, but for the demo it would be too long, so I changed it to 30 seconds. And then on the right side, we have the trigger. So we have a type. In this case, it's going to be Azure Service Bus. And then we have what queue we want to scale based on, and the queue length. So this value is a bit tricky because it means we scale if you have more than 5 values or messages in the queue. And lastly, we have a reference to the authentication. So the name is Trigger Authentication KEDA Demo API. And that's also the name of the second object, the Trigger Authentication. So here we see the same name. So the scale object is referencing this file. And here we have a reference to a Kubernetes secret. And the secret is named KEDA Demo API connection strings. And this secret has a key that's called Azure Service Bus connection string. And this key holds the connection string to the Azure Service Bus. So if you're in the command line, you can say kubectl get secrets. Then there you can see the secret name. And then you can say kubectl describe secret with the secret name. And then you get the key that you referenced before. And you can also see the same if you use a dashboard. You just go to secrets, click on the name, and there you can see the key base64 encoded. Okay, now it's time for the demo. Do we have any questions so far while I set up the demo quickly?
No questions so far.
Okay, so let me zoom in a bit. I just have to probably log in again since my computer restarted. So it's just gonna be 1 second. So now it should hopefully work. So I've prepared a namespace. Yes, so the KEDA demo API test. Set the context quickly so I don't have to type so much. I'm just telling Kubernetes that I want to work in the KEDA demo API test, so I don't have to edit to every command I write. And now I can see there's one pod running, but this pod is for the TLS certificate. So there's nothing from my application running. And what we're going to do now is we just monitor this if something is going to change. And in the meantime, we go to the Azure portal. And here I have the service bus queue. And right now you can see there are 0 messages inside the queue. And now what we can do is we can send a message. And post this to the queue. And now within the next 30 seconds, KEDA should see that there's a new message in the queue and will scale from 0 to 1 to process this message. So I hope that's not going to take too long. There you can see already the container is being created and it's running. So we can see here with the KEDA demo API container running. That's just not ready yet. And now you can see it's ready. So we scaled from 0 to 1. And now we can simulate that we have Black Friday, many messages coming in. So we post more messages to our queue. Let's say more messages, and we post 300 messages. And now KEDA hopefully will see that there are more than the 5 messages we configured, and the scaling is already happening. So KEDA sees there are many messages, so it has to scale out, and it will scale to 10 pods because that's the maximum I configured. So let's give it a couple seconds, then all 10 pods should be available. And there you can see they also have different times. For example, this one was the first one we created. Then there are a couple here with 34 seconds ago, because KEDA scaled and then saw that there are still so many messages and scaled even more objects, more pods.
Yes. Hi, Wolfgang. We have a question, so I'm interrupting.
Sure.
All right. So we have a question from Jerome Thin. For the service bus connection string, what is required? What are the required permission for authentication with KEDA? Listen is enough?
List should be enough, but you have here these access policies. And in this case, I've managed send and listen, but listen should be enough, I think. But the documentation of KEDA is great. And I think you also have a link to a blog post where I described exactly how to set this up, which you, I think, said going to share later. If not, I can share the link.
Yes,
Or I
you
can
find
talk
it.
after the session.
All right. Thank you.
Okay, now we can see all 10 pods are running, and we can say they all are processing our messages. And now we can again simulate that we received all these messages and delete them from the queue. So we have again 0 messages in the queue, and now KEDA should again see that there are no messages and then scale down accordingly. So hopefully, yeah, there the termination is already happening. And now all the pods should be gone. Exactly. Now I can see we have 1 pod running, but again, that's the pod that's matching the TLS certificate. So we successfully scaled out and scaled down to 0. And for you, if you want to go through the slides later, I've added screenshots of everything I just showed you, so you can see what was going on. And one thing I couldn't show you today because I have a second demo where I needed more resources is that it can happen that you have here a couple pods that are pending and a couple pods that are running. Because when I created the screenshot, my cluster ran out of resources. So that's something you have to be mindful. Don't just add 100 pods and say it doesn't matter, just scale it up. You have, especially on-premise, only a certain amount of resources, and you have to be mindful of the scaling you do. And also what's important is only scale to 0 when you have like background worker or something that's processing. Because if you have a website and you scale it to 0, it's not available for your customers. And it also won't be available because the customers can't access it, and so KEDA won't pick up that it has to scale out again. Then what's probably interesting is more for the operation side is the logs when scaling is happening and what happened during the scaling. So the KEDA operator writes these logs, and you can see, hopefully you can read it, that it writes the target. So in our case, the application was called KEDA Demo API, and it also scales from what amount to what amount it scaled. So in this case, it scaled from 6 pods to 0. And back here, it scaled up again from 0 to 1. So you can exactly see how the scaling worked. And if you have any problems with that, just go and look in the logs. There you should probably figure out what's going on. Then very great tool. There are some limitations. The first one could be that the scaler you need is not available for your technology. As I said before, you can create the scaler yourself, or you can create a pull request as an issue on GitHub and hope that someone else will implement it, or just talk to the community. And the second problem you can run into is that your cluster runs out of resources. So we have here the example again that some pods are running, but several ones are still pending. And if you inspect one of the pods, for example, the first one here, you will see in the events that it says insufficient CPU. This means my Kubernetes cluster didn't have enough CPU cores to schedule the pod, and so it couldn't start it. There are certain ways around it. If you're using Azure AKS, you have the Azure Cluster Autoscaler. So Azure just adds more VMs to your cluster. The problem is it's becoming quite expensive if you just add more and more. And so I would recommend that you define replica limits that make sense. For example, try with 10, and if you see you never reach 10, 5 is enough, then only say 5. Because if something happens, you don't want to overflow or overload your cluster and bring it down. And always monitor your cluster. I think that's a general good tip in IT. Monitor what you're doing, what's going on, so you know if you need more resources, if your application is running fine. And with that, I think you're good to go with KEDA. So another example I want to show you, just to show how versatile KEDA can be, is to run an Azure DevOps agent inside Kubernetes, and then we scale it from 0 to how many we need once we start a pipeline. So the steps we have to take is we have to prepare Azure DevOps first. Then we're going to build a Docker image locally, also test it locally. Then we deploy it to Kubernetes, and then we apply KEDA. Since we don't have too much time, I prepared a couple of the steps before. So first, you have to create a personal access token in Azure DevOps. And you have to have the agent pools permission or scope to read and manage. And what's very important is when you create the access token, it will be displayed once and once only. So if you don't copy it there, you have to create a new token. So copy this value. Then you go to agent pools in your configuration and click on the top right, add pool, and add a self-hosted agent pool there. Then you give it a name. I give it the name KEDA, and you create it. And then there's a Docker file that's provided by Microsoft, and I also have it on GitHub, where you get the link later. And what this Docker file does, it prepares the Azure DevOps agent. So it installs here a bunch of software, here more, and at the end it starts this start.ch file. And this file configures the Azure DevOps agent. And since you have this Docker file, you can add all the software you need. For example, by default, the Docker file looked like this. But I want my Azure DevOps agent to be able to build .NET 6 and .NET 7 applications. So I added the wget command and then used this to install the .NET 6 and .NET 7 SDK. And also what's very important is the start.ch file needs the Linux file, end of file, because I saved it once under Windows, and then it took me hours to figure out why it's not working. So if you try it and you can't build a Docker file, save it with lf, end of files, and then it should work. Once you have configured the Docker file, you can just build it. And it's quite a big image. I think it has 1.5 gigabytes, so it takes a couple minutes. And I think I prepared this. Yeah, so let's let this run in the meantime. And after the Docker file has been built, all you need to run your Azure DevOps agent inside the Docker container locally on your machine is you need the personal access token you created before, you need the agent pool name, also the one you created before, and you need the URL to your Azure DevOps agent organization. So while this is building, I'm going to show you the pipeline we're going to use. So I've created a pipeline here. And this pipeline does literally nothing except execute an empty bash script just to check if it's running. And the only important thing is here that we have the pool set to KEDA. That's the agent pool we have created before. And this pool will contain the Azure DevOps agent that's running inside the Docker container. Let's see if this is still not finished. So instead of waiting, I'm just gonna show you what I want to show you live. So after you've built the image, you can say docker run, and then you provide the values as environment variables. So you have here the URL to your organization, the access token, then you provide any name, you provide the name of the agent pool, and lastly, the name of the image you just tagged. That's going to take a couple seconds, and it starts the Azure DevOps agent, and then the agent will just wait until it's ready for running. Then they have the pipeline again, and when you execute the pipeline, the agent will pick it up, and you will also see in your console that here it's listening, then it was running, and in the end it succeeded, and also it removes the agent. So after the agent ran once, it's going to be removed. So if you want to reuse it, you have to restart your Docker container. So after you tested it locally, you can tag it with whatever you want and push it to a container registry. In this example, I pushed it to Docker Hub. So if you want to try it out, you can just take the image from there. And then we can prepare the configuration for Kubernetes. And for this, we have here this deployment file, and this file creates two resources inside the Kubernetes cluster. The first is a secret. This contains the Azure personal access token. The only difference is that you have to encode it in base 64. That's just how Kubernetes works. And then we configure what image we want to use. So here, that's the same image I just pushed to Docker Hub. It's the URL of my Azure DevOps organization. And here it's again the name of the agent pool I configured before. And as you can see, if you want to try it out later by yourself, I added everywhere these comments where you have to change something to make it work.
Yeah, so Wolfgang, we have another question here.
Yes.
A question from Samir. He says the access token will stop working after certain days, or can it be set to unlimited? Or how are we supposed to work with security of PAT tokens in this case?
That's general a problem, I think. You can set it to a maximum of 1 year. So the only solution I found so far is to set a calendar entry a week before it expires and just refresh it so it doesn't expire. But what I see most of the time is everything works, and after a certain time it doesn't work anymore because nobody thought about refreshing it. Then it takes a bit to figure out what's going on, and then a new token gets being created. So yeah, unfortunately, there's not a great solution to that.
Okay, thank you.
Okay, the image has been created now, so it took around 2 minutes. But I already showed you. You can test it locally, and if it's working, then we continue. So we already have pushed it to Docker Hub, and now we wanna deploy it to Kubernetes. And to make it easier, we create a new namespace and deploy it into this namespace. And I'm gonna set the context to this namespace again, so I don't have to type it all the time. And then we just apply this deployment file I just showed you. And now we have to wait again. Oh, it's already running. So at least that worked. So now the agent is running inside the Kubernetes cluster. And if you go back to our Azure DevOps, don't need that, to our Azure DevOps agent pool, here we have the KEDA agent pool. And there you can see we have this agent and it's online. And if you want to use KEDA, you have to disable this agent. That's a limitation of Azure DevOps. Azure DevOps needs at least one agent inside an agent pool. Otherwise, you can't use it to schedule it for pipelines. So that's a limitation you have to know. And once it's disabled, we can now create the KEDA configuration and then use the KEDA agents or the agents that are scaled by KEDA to run our pipelines. And for this, we have another file that contains the two objects I told you before about KEDA. So here we have the scaled object, and that's configuring what we want to scale or what application we want to use. So again, we reference the image from Docker Hub with the URL to the Azure DevOps organization, and we have the name of the agent pool. And also, we have to add the pool ID. And what's very important is that this is a string, that's not an int. And you can find out the pool ID via the CLI, or you can also just call this URL, replace it with your organization, and then you get a wall of text. And you can just with search and find the name of your agent pool and find the ID there. I actually can show you quickly how this looks. So if you enter this, it's like a big wall of text. And if you search for KEDA, that's the name. You can find it here. And here you can see the ID is 14. So that's the value we put in the configuration. And that's all you have to do, actually. So we can apply this file now. So it has been created. And then we can just check what container are running. And if you go back to our Azure DevOps pipeline, I have a second pipeline there with multiple jobs. And this pipeline again uses the KEDA names, KEDA agent pool, and the jobs are again very simple. Like here's the first job, and it does nothing but sleep for 5 minutes. That's just to simulate having in total 5 jobs. So if you run this now, what we expect to happen is that KEDA sees there are 5 jobs queued and it will scale 5 Azure DevOps agents, and then these agents process these jobs. And there you can see a container already being created. So it's going to take a couple seconds, and then the jobs should start running in Azure DevOps. So in the meantime, until it's starting up, I can show you. This is the reason why we had the outage before. Some very excited kitty. Okay, now we see the agents running with a total of 5 agents. And if you refresh it, we can see 2 pipelines are running, but not all 5. And that's again a limitation of Azure DevOps. In this case, it's a licensing problem. My Azure DevOps organization only has licenses for 2 parallel jobs. So Microsoft only allows me to run 2 jobs at the same time, even though I have 5 agents. And KEDA obviously doesn't know this. So KEDA sees 5 jobs and starts 5 agents. So now these 2 jobs are executed, and when they're done, the agents are picking up the next 2. But as you can see, it's working. We scaled from 0 to, in this case, 5 agents, and the agents are executing our pipelines. So again, I added all the screenshots of what I just showed you to the presentation if you want to go over it later. And you can also find all the code on GitHub. So the limitations, I told you already before, the Azure DevOps pipelines supports scale to 0, but you have to have at least one agent registered. That's why we created the agent and then deactivated it. And it also can't queue a job if there's no agent. And as I said, you only can execute as many jobs at the same time as you have licenses for that. And then there are some limitations or kind of problems with KEDA. When you cancel a pipeline, the pods just continue running. KEDA doesn't know that the pipeline has been canceled. And also, KEDA doesn't remove pods that are completed. So after a week, you will have a whole bunch of pods of offline agents laying around, and yeah, they'll just fill up. The only thing you can do is you could have a daily job that's just removing all these offline agents, all these finished pods, and clean up a bit. Then my opinion about KEDA, if you can use it in production or not, what's going on. So Microsoft is using KEDA for various Azure services. We've heard before for Azure Container Apps. So if you have Azure Container Apps and you want to scale them, KEDA is being used for the scaling. And the same if you're using Azure App Services on-premise with Azure Arc. Then Azure Arc also installs KEDA, and KEDA is taking care of the scaling of your app service. And about history, it has been introduced in November 2019. And it's currently version 2.10, I think 2.1, and it has more than 6,000 stars on GitHub. So it's a very popular tool. It has a great community, and Microsoft is using for their services. So I don't see any reason why we can't use it in our projects. It has great support, big companies behind it. So yeah, I would recommend to use it if you need it, and it will help you a lot. And a couple of resources, you can find the demo of the KEDA scaling on GitHub, also of the Azure DevOps agent. Then there's the KEDA website and the KEDA GitHub. There's also some great resources. The documentation of KEDA is quite good. And if you're interested in the slide, you can find them via this QR code again. So if you have any questions, feel free to ask now, or if you have questions later, contact me on LinkedIn, Twitter, or send me a message via my blog post, via my blog. And with this, we're at the end.
All right. Yes. Hi. Thank you. Thank you so much, Wolfgang, for the amazing and great session. Learned a lot from your session. We don't have any more questions from the audience, but I do have one. Maybe I can insert for our last minute. I work with DevOps also, but I'm curious. I really like your demo about the ADO with KEDA, and you highlighted the limitations there. When would I consider using Azure DevOps agent with KEDA compared to Azure VM scale sets? Because VM scale set also has scaling, right?
Yeah,
When
exactly.
yeah.
I would consider it if you have a Kubernetes cluster on-premise, so you already have your hardware and you just want to use it. You don't want to pay for Azure services.
Okay.
But if you don't have this, I would go with Azure because they have everything. You don't have to maintain it, so it's easier for you.
Yeah. Okay. Thank you for that, because I was like really close to say, oh, I want to try it when I saw your demo. All right.
Also,
yes,
what you have
thank
to
you.
think about is, since it's running in Kubernetes, you can't build Docker in Docker. So you would have to use Podman in your pipelines, and then you can build it in Kubernetes. So it's
Okay.
also a bit more work than just execute a Docker file.
Yeah. Yes. Thank you for that. We do have feedback from our audience. Ashish, excellent session and demo. And he already connected to you.
Yeah,
Great.
great.
Amazing. How about you, Håkan? Do you have any questions to Wolfgang?
No, not as of now here, but I think if we can show again here this Zoom link
Yes. Yeah.
for the people who arrived late.
Yes. I can also add the link on the chat, I think, to those who wants to join us later
Mm.
after this. Yes, I will continue our discussion, or we will do that after this to those who want to join. Are you able to join us also, Wolfgang? In a few
Yes, I'll be
minutes?
there.
All
Uh,
right. That's
See you there,
great.
hopefully.
Yeah, so our time is out. So I'm very thankful to Wolfgang for your time and for sharing your knowledge and expertise on this topic. And feel free to follow Wolfgang on his blog. He writes amazing content about different things, including microservices and containers. So yeah, I think it's time to go for now and then continue on the fika. But if you missed claiming your Azure Learner badge, feel free to do that if you just joined us in the middle of the session. So thank you for learning with us. And in 2 weeks, we also have another session coming up. So feel free to register. Anything else, Håkan, before we let them go?
No, yes, wish a very nice weekend to everyone and hope to see you at the fika.
Yes. See you and have a great weekend. Bye bye.
Bye bye.